Okay, so what do we do? We magically schedule meetings. What exactly does that mean? So this is on the left side, the pane column is how you typically schedule a meeting. Let's say at the end of this chat, you send me an email, say, Alex, let's grab coffee sometime next week. And I say, sure, just if I have an assistant, I would CC, Amy in and say, hey, just coordinate with Amy. And then kind of what typically happens with a personal assistant is that the assistant will take over that conversation, start sending you a set of emails saying, hey, Alex is actually not free next week, but he is available for coffee next week at 2 p.m. on Tuesday, and so on and so forth. So you had that back and forth with Amy instead of the back and forth with Alex, like you typically would know. Sorry. So that's what we do. And the question is then how do we do that? And so we think about it, there's really 4 different areas, or 3 different technology areas that we are attacking. First, we need to understand the email that you sent in to us to have this, be able to have that conversation with you, right? So natural language processing and natural language understanding is a big piece of what we think, big piece of our product, which part of what we'll talk about today in terms of the architecture powering that. But the second piece is actually the conversation. How do we be able to actually have a conversation with you? Because when you email us, we actually have to email back, which is very different than some of the other system out there that you used before. That is more of a query-based system. For us, it's more of a conversation-based system. So now thinking about before talking about the database choices or data architecture or how we model data and so on, I just want to, given that's the product, I want to talk a little bit more about so what does that mean in terms of characteristic, and then after that talk about the technical choices that we made. So we need quick response time. So I make the distinction between that and real time because I come from a real-time world where our last venture is in real-time analytics. And for us, real-time, there is a separate meaning to this. For us in x.ai, dealing with emails is you want to respond quickly, but losing 5 seconds in the processing, for example, is not a big deal, right? So we want quick responses, but we actually have some luxury in not having to do sub 100 milliseconds response and so on and so forth. Another thing about it is that we apply a lot of machine learning, and we need a lot of data for machine learning, and so being able to have a backend that support this large kind of backend machine learning is important to us. Again, compared to our last venture, which is in a real-time perspective, where you more of on a stream processing, here is more about offline training, right? Something that we can train the model. Again, we have the luxury of time in processing and building the model, and then so that it can support the real-time or the quick responses that we need in sort of production environment. In terms of scaling, so we certainly sign up customers to use our service, and every customer schedules X amount n number of meetings. So as more users we add, we linearly scale up the number of meetings, which in a way that's the key metrics that we follow. And for every person, you meet with X number of people, right? So as I schedule coffee with you and so on, and then so it is this idea of a graph that starts to emerge, if you think about it. And then there are different data sets that are being shared, right? So all of us are showing up at Spotify today. That some of you might have your favorite coffee shop to be Grumpy's. We might have, we work at the same company, and so on and so forth. So when we model this, the data, we have to take that into account of that we have a unique users who are in various meetings, who are with other people, but might not share some of these other attributes or entities. So with that, what are the challenges then? Being able to build a conversation robot compared to some of the other natural language or machine learning technique is that our challenge is being able to achieve a extremely high accuracy. Because the last thing we want is that experience that you might have with, say, Siri, to say, you know what, she doesn't understand what I'm saying. We want that experience, back to my second slide, magical. We want that conversation to be so natural. We want that conversation to, that is our interface. Right? We don't have an app. We don't have a website. I mean, we have a marketing website, but you interact with us with just CCing Amy into the product. So being able to have that natural conversation with you, being able to understand what you said before, understand context on the conversation that we are having with you is super important to us. And that requires a different set of focus in the technology. Second piece of this idea of having a conversation. So for example, if I just email you and say, hey, I'm free next Tuesday at 5 p.m. and Thursday at 2 p.m. And you just email me back and say, sure, 2 p.m. works. What is that? If I just analyze at 2 p.m., what does that mean? Without context, I couldn't narrow it down to what you actually meant Tuesday at 2 p.m. So being able to carry that context, which again is a bit different than, say, if you're doing a Google query, that you just say, you know, who's Abraham Lincoln? And then if you say, next query is, say, when is his birthday? Google wouldn't tell you when, because it really lost context in the process. I'll show a little bit more about kind of the data structure, but yeah, certainly there's a bunch of different relationship between different entities in our system, which we have to take that into account as we pick our database and model our data. I think it's pretty natural or pretty common for natural language processing and machine learning that you deal with a lot of sparse data. So for example, if you're working with a lot of text, we're keying on, let's say, n-gram as a feature, that we're picking out specific words that appeared out of the many millions of combination that you can have on a 3-gram, for example. So being able to take that into account. And then we want to change fast. We want to be able to make changes. We are a startup after all. We've only been around since April 2014. So being able to pick technologies and data models that are flexible enough to allow us to add features, to iterate, and it's super important to us. So here's our stack. Everything's hosted on Amazon. We do use quite a few of the Amazon services, including SQS, the ELB, and so on and so forth. I will tell you more about the database. Our backend and data science are all done in Scala. We do have, back to the point that we don't have any apps, but we do have some internal web apps and some of the websites that are powered by Node and Angular. So with the technical challenge that I just mentioned earlier, we are not processing an insane amount of data partially because of people do have to actually email us, right? So it is the number of emails that we care about, in part of it in a scaling perspective. But we care about every single email. We do a lot of things to every single email. We do tons of processing. So in a way, that's the challenge of being able to make sure that we don't lose any data, and then we are processing all the data. Again, coming back from my prior venture where we are doing big data analytics, in which we're doing counting a lot of data, we're counting page views and aggregating page views and so on. But if you lost a page view, it's actually not the end of the world. Here, we cannot lose a single email. It is super important that we both not lose and process. So with that, we put in the queue-based architecture. So when an email comes into what we call a receiver, which really is a receive the email in a thread, into certain email conversation threads, and then quickly put it into a SQS queue. After that, we have what was the annotator. So this is a quick version of our NLP pipeline in the beginning on a very, very high level. But the annotator sort of extracts sort of the entities that we care about. So for a meeting, if you think about it, is we really care about 3 entities. We care about who should meet at what time and where. So those are the 3 sets of entities we're particularly interested in. And then be able to classify the email itself into a set of what we call intents, understanding of what are you trying to say to us. So when you say 2 p.m. works versus 2 p.m. doesn't work, we need to understand that, right, even though there's the same time entity. We pick SQS as a queue, partially is ease of use. We do like the sort of free scalability that it brings to us, that it was really relatively easy to add into our infrastructure, to give us that safety in a way that, if we want to take down the annotator for 5 minutes, we could. It just sits all the email just sits in the queue, and it brings it back up, and again, without losing any data, which is very important to us. And there are some challenges with SQS. For example, the maximum payload is 256 kilobyte. So if you have big messages, and sometimes our emails are quite big, we can't fit it all in the payload. So I mean, we do have our database, our payload. For some of these processes, we store the payload in our other database, and pass along just the ID of the message that we need, and then we count the ID. So kind of with the architecture in place, how are we going to pick our database when we first started the company? Again, starting with some criteria that we care about. We want to be familiar with the technology. I mean, we love trying new things, but at the same time, if we can find something that we are familiar with, it adds to the speed of building new things. So we want to be innovative in the AI machine learning space, not in database technology per se. So with that, fitting in with the startup environment, we want something that has a low initial maintenance. Like we do not have a dedicated DevOps team that we really don't have time to care for the database that much. I mean, we need to have an understanding on it and be able to utilize it to its fullest, but that's the trade-off, right? Because at the end of the day, I don't think there is a perfect database. I think there is a best choice for your application, for the stage that you are at. And I think that's the evolution of architecture and database in general. So to us is how do we match a database that is important to us for our current use cases. So yeah, back to the iteration and speed piece. We want something that gives us flexible schema, because we're not quite sure. We're pretty sure about what the schema is going to look like, but as users start use the product, we start thinking about new use cases. We want to add, subtract, change how we modify our data storage and how we model our data, and being able to quickly do that is important to us. Again, finding something that's easy early scaling. That we want people to scale somewhat with the initial database, but I certainly don't need it to scale all the way to hundreds of millions of users. But some scaling will be nice. And then having reasonable production quality, right? Being able to provide that certain safety that we know we can run a production system on it, but willing to trade off some of the really deep production infrastructure with some of the low initial maintenance and flexibility as we go forward. So we picked Mongo as a choice. Again, from a prior venture, we ran a Mongo cluster, a sharded Mongo cluster before, up to processing 15 billion page views a month. So we know it scales pretty well, although to be honest, at that level, it starts to not work very well. So I think if we ever get to that level, we have to have another discussion. But what do we get from Mongo though? It is schemaless, that we can we can store complex dictionary in them as we need, however, and we can modify them on the fly. That does have is actually a pros and cons, but combining it with the second point makes it make life a lot easier. Having Mongoose as an add-on, which Mongoose give you a schema control, right? You can although the database itself doesn't restrict anything about like what you want to put in, we actually in our code define the schema, so that like when we do change it in the code, we actually don't mess up what's in the database, which is something we got burned before from a prior venture, where when someone just some 3 services upstream just decide to cast something instead of an int to a character, and then all of a sudden your app start crashing down the road, and you don't know why, and you're just grabbing this data from the database. So we want to prevent that from happening. It does pretty well work out of the box. We gave very little maintenance. I mean, we do have a lot of working knowledge with Mongo, but yeah, it really did kind of just work out of the box for us. So that was very nice. And having a replica set is actually quite nice. It gives us the safety of, if your master database failed, the slave would take over automatically, again, with really little maintenance required, and we can keep scaling up the repo set by scaling up the machines instead of actually sharding, which I'll talk about in the con side. And then, Mongo does provide the monitoring service, which is the MMS, which is actually, again, pretty good right out of the box, give you pretty decent analytics about the performance of your database, and alerts come free with it, and then all the nice pretty graphs come free with it as well. And as an early startup scaling, that is actually quite nice. So those are all the pros that drove us to picking Mongo. Cons though. So being a schemaless database in Mongo, we actually doesn't do joins within the database. So every time we have to join data, it happens in the application level. You have to pull all the data, do the manipulation, and then combine data together. It's just become a different pattern that you certainly lose some performance in that, but performance that we won't trade. It is a pain in the butt to do backup yourself. We've done it before, and it's supposed to work pretty well. You have an additional slave, and then you take that slave offline, you do a Mongo dump, and then you get the dump, and then you attach the slave back into the repo settings, should just work. But then sometimes it's because of the voting system, or if it just happened that one of your other node also failed at the same time when you took off the other slaves. It's just kind of production nightmare. But the pros actually on that is that Mongo does provide as a service, a backup service, which we use, which sort of solve most of that problem. We certainly want to do backup more frequently. I think they do the backup every 6 hours. So, but at least that's decent for what we're looking for in terms of safety. And then the last 2 points is really, when you're running Mongo at scale, is something that we certainly don't want to do again. I think sharding Mongo is not something that's fun, and across data center deployment is also not awesome as well. And I think once you get to that level of scaling, a lot of the nice thing that we got from the beginning, the low maintenance, right out of the box, all those things kind of go out the window. All of a sudden, you need to support it. You need to really understand what's going on within Mongo, and so on. So, so when we get to that point, we certainly want to rethink kind of what we want to have in terms of a database. Oh, sorry, one more thing. When we were running Mongo, we were using Mongo version 2.6, which is the difference right now is Mongo version 3, which we just upgraded to. But one key feature is missing, which is document level locking. So when you are accessing, for version 2.6, they have database level locking. So when you're accessing some document in the database, it locks the whole database until that instruction is complete. So which actually drives us into having a lot of different databases just to work around Mongo's limitation of not having document level locking. Again, that had been solved with the new version of Mongo, but that was a pain that we dealt with for a long time, and actually made our database architecture a little bit more complex than we would like. Okay, so with the database in place, we want to start. I want to give you a few examples on how we model our data and how we think about it. So this is an excerpt from our a meeting model. Right? It's a lot longer, so I just picked out a few fields. So right there, the first line is a host, which is what we think about our user, the host of a meeting. Right? And then that host will be meeting with a set of a list of participants. And then the meeting has a start date and an end date, and then recurring rules. If you never worked with calendar before, recurring rule is like the worst thing ever. It's the most complex things you can think about on how many exceptions there is. On you think like you want to meet every Monday, and then all of a sudden but every Monday, but next Monday, or but the next month I want to remove 4 of them. Like how do you represent that? It's just super painful things to model. Yeah, then time zone, how long is the meeting, durations, and location. Now I highlighted some of these in blue. The participants and location, which is really a separate entities, a link to a different database. And I'll talk a little bit more about like why we did that. So yes, quickly think about some of the key entities we have in the system. So, again, we do meetings. That's what we do. And for meeting, there's a lot of people in the meeting. Could be you and me. Could be those 3 gentlemen over there. Could be so on and so forth, right? But then, we might be in each other's meeting, right? Like, I could be a host in one meeting and then a guest in a different meeting. I might be participant in 6 different meetings, and those are things we need to keep track of, right? But then the people share other entities. Like back to what we talked about, places. We all work at Spotify, or we all work at x.ai, or we all like to go to this coffee shop. So on and so forth. Those are the sort of either one-to-end or end-to-end relationship that we have across these different entities, and that's certainly something that we want to take into account as we model the data. So one major decision that we made when we modeled the data was about, should we embed everything, or should we start referencing to create kind of other entities and reference them across the database. So the way we make this decision, so actually let me give the quick example. So for the embedding version, the host actually has a name, a nickname, a phone number, primary and secondary email addresses, and a bunch of other stuff that come along with a person, right, a participant in this meeting. And then for the referencing part, we actually took that out into a participant database, which had kind of just abstracted that outside, and then so we can just reference that in the host field. So what does that mean though? So that means if you're doing referencing, if you ever want to query, like understand, get the full view of the meeting, you're actually making 2 queries, right? You query for the actual meeting, and then you have to go in and say, oh, give me this ID of the participant, and then I do another query to get that data, to fill the database, right? Or to fill the data. So some of the things we have to think about is, how are we doing the majority of our queries, or the queries related to this set of data? Do we want to make these multiple queries for the filling, or what are we trading off on? Well, the trade is that also, are we going to access the individuals? So for example, like for the participant case, do we ever want to just know this person, their name, a nickname, and so on and so forth? And then do we have other databases that are referencing the same entity as well? Because when you do, then those are the times that you want to start thinking about referencing. You start to be able to access the subdocument that now in itself is a major document, and then you can be able to start linking across different databases or different entities, which give you much better scaling in that sense. Yeah, I mean, we have to do application level join for Mongo. So the question is how many of those you want to do based on, again, the software's usage. For cases, if you are referencing, so pretty much everything in our production is a one-way referencing, so that there's inside of a meeting there's a participant, but then in production we don't look at like for each participant how many meetings. I mean, we could do those queries, but we actually end up not needing it in production. So that prevents us from having to do two-way referencing. The problem with two-way referencing is that now you actually lose atomic updates. Every time if you're actually relinking a link, you have to actually update it in two places, and then you run the risk of one of your updates actually fails, and then now you have messed up data. Here's another example of how we were iterating and think about our data model. So someone else's assistant. So we are someone's assistant, but sometimes, and actually more often than you think, we end up having to work with the other person's, the guest assistant. So they say, yeah, Amy, great, go talk to my assistant. Have the two assistants talk to each other. So we're trying to figure out like, what is the best way to model this assistant. At first, we started off the simple case, assistant is a person too. So let's just make that assistant a person. So it has all the other attributes that other people would have, with name, nickname, and phone number, and all these other things, titles, signatures, long lists of fields. But what we realized is that people only give us the assistant's name and the email addresses. So like it's just a bunch of empty fields. It's just kind of the not very optimal way to represent the data, and it just makes things a little bit more complicated along the way. So after seeing that more often, we decided, you know what, let's just, for the second try, let's just make the assistant an attribute of the person, so that like you have an assistant, cool, that's fine, that's your assistant, and then we just work with that, and our logic start dealing with, or whenever we detect that we were working with an assistant, we will start addressing the assistant and not talk to you, but there's a bunch of little logic that we put together to work with an assistant that is actually different than how we work with a regular guest. The problem of the second try is that then we start bumping into cases where one assistant works for multiple people. We're like, crap, we don't know what to do with that. And then also, the assistant wants to schedule their own meetings too. So now the assistant is a person, but also an attribute in someone else's document, and it's just becoming a mess. So we've gone to a third try, where assistant is a separate entity, but actually we just abstracted all the small, just only the necessary stuff. First and last name, primary email. So that we can actually cross-link, link the assistant to multiple people, and then they're individuals, and we can query them, query against them if we want to. But that certainly took a bunch of iteration and then seeing real-life cases on how we would want to model this particular data. So just want to share with you, being an early startup, a blunder that we made as well. So being an AI machine learning driven startup, we care a lot about our data and then how we store them to optimize it for data science and machine learning and so on. But even with all the care and love, with us moving fast and pushing features, we did end up actually messing up the data at some of the earlier time. So what happened was that we pushed a few features that we stopped. We set the character offset in the marking where certain things are in the text. We stored it a little bit off. It was just based on different logic. Sometimes we misrepresented the time, or the time zone is messed up. or sometimes we forgot to set the proper send date, or we actually somehow set the wrong one. So an example is there's some record that have like the send date of 2026, which I'm pretty sure we didn't go into future and send those. And then yeah, sometimes we just completely missed, and we forgot to store some information when we push some of the changes. So a big, not big, so one project that we ended up doing was that how do we go back and fix some of this? So we actually wrote a piece of code that from a guy who was sitting over there, kind of recalculate a bunch of this data, like reset the offset, change, kind of reconstruct the time entity from other contexts that we know, reconstruct the time zone. And then like after all that, we were able to salvage most of the data. And then yes, for our data science, making sure that it's accurate, we did end up dumping the small portion of data that we could not salvage. But that's part of moving fast. You can't always plan for everything, but more about recovering fast and figuring out the best way to move forward. Okay, so I talked a lot about data. It's hard to not talk about machine learning and AI for us being us. So I'll end the talk with a couple of slides on our architecture for data science, or how we power data science. So the first piece is, how do we get data to our data scientists? We want to give them as close to live data as possible. As much as we love them, we don't want them to be mucking around with our production data or messing up our performance in the production environment. So this is what we came up with, and this is what we have right now. So inside of the virtual private cloud, there's our production data, master, slave, replica set. And then because we use Mongo's backup service, which periodically dumps our backups, we just restore them periodically into a totally separate environment, in a totally separate virtual private cloud, and then just have that into become the dev database, so that the data science can do whatever they want in that database. They can completely delete the database, they can do whatever they want, we can always restore that. And then we can create another separate machine learning or data science database where that's where they store sort of the derived data. So whenever we do a Mongo dump update, restore, we don't wipe out all the data that they created. So this has been working pretty well for us, I think. Just enable us to be able to work on or get a data scientist some pretty close to real-time data without really messing up anything or taking any risks on the production environment. Now finally, so how do we train our data? So this slide in itself could be another 20 slides. So pardon me for being a little bit high level. So how do we train the model that we used in production? For raw data, one of the first things we do is clean it and filter it. Partially is actually to clean out and reconstruct some of those bad data that we talked about, but then also making sure that all the data is in a certain level that are important to us, that had all the right attributes. And then we augment it. A lot of the different techniques that we use in the backend leverage similar features and leverage similar pipelines. So we centralized it, right? So we would do kind of the POS tagging or the name entity recognitions, or like construct the pass tree that are there, kind of so that all that data, all the features that will be available to the kind of next line in the pipeline without every single data scientist have to reconstruct their own tags. And then after that, we transform it into the set of features that we care about. It's features that like n-grams, or thinking about what did we say to the customer before, because again, we're having a conversation, and whatever we say actually has an effect on how they respond. So that set of features all get created so that all the downstream machine learning processes can pick and choose whatever data set they want, or whatever feature that they want to do their own predictions. So that's a super high level on how we do model training. And of course, one thing about the transform piece is that back to the sparse data, we do have to create a sort of dense representation of the sparse data set, so that it's pretty much a dictionary, right? That you can say, hey, if you do an n-gram and say, let's meet at is a 3 gram that appear in this particular slot, but then all the other things are 0, so there's no need to represent the zeros. But then, of course, when we actually do some of the classifier and other machine learning algorithms, we need to actually expand it back out into showing all the zeros. So that's where the vocab combined with the dense sparse matrix, and then opening it back up for the machine learning to actually churn through. That's us, and happy to take any questions. Go that first, go ahead.
Do you guys have any problems dealing with daylight savings time?
Do we have problem dealing in daylight savings time? Yes, we deal with it. As I said, as my co-founder, I said, like, laughing. Yeah, absolutely. Time zone is one of those. Daylight savings time is like our best friend. But yes, we do, and it's just something you just have to take into account. Yeah. Go ahead.
How does Amy know about the context of the person that she is the assistant to, the AS assistant to, like, the person, what city they're in this week, or they have a doctor's appointment that week? Does she have access to their calendar?
So you're asking for how do Amy knows the guests in the meeting on if they are working with another assistant?
No, the one who she is the assistant for. So if I want to schedule a meeting with you,
yeah,
and I'm talking to Amy, how does the AI know, like, this week you're in New York City, but next week maybe you're in Chicago?
Yeah. So how does the AI know your travel plan? Right. We know some. There's certain knowledge that you have to tell us, right? Like you have to tell us. But there are signals that we can key off on. For example, that you might mark on your calendar that you're traveling. You might use services like Tripit to tell us. So there's certain data available, but even then it might not be as clear cut as it could be, right? Because you could be going to South by Southwest. Yes, you're traveling, but you're definitely taking meetings, right? Or you're traveling to a conference, or you're willing to take phone calls. So some of those nuances is that we will make some good guesses, and then when we make guesses, we'll generally come back to you and let you know that what kind of assumptions we're making. But to be honest, that's certainly not a data set that you can just completely know without informing. Yeah. Go ahead.
So you mentioned a few times like favorite coffee shop or meet in this conference room or whatever. So there's a lot of metadata that's involved there. So conference rooms can only fit a certain number of people, or coffee shops might not have Wi-Fi. Is there a manual onboarding process to learn those places, pieces of data and properties? Or is this something that just gets fixed over time as it learns more?
So onboarding is something we think about a lot. I think it is a big piece of what we will continue to be working on, partially because we don't have an app. So in a way, everything is invisible. So we actually have to drive that onboarding and let you know what is available, what you should be setting, and so on and so forth. But I do think that on onboarding, it will be quite different than your sort of typical onboarding in a way that we would depend on our knowledge, right? For example, since we have your calendar, we could do things by analyzing your calendar before you even use it at all, that we can see, we can get a pretty good guess again on what you like, where do you meet, and so on and so forth. What's your typical start date, or start time in your day, and when do you end your day? Good guesses, right? So we can come back to you and say, these are what I got. Does it jive with what you actually think? And so yeah, it is a work in progress for sure. But yeah, I think it is a very, very important piece of our technology. Go ahead.
Does this only work for English?
Right now it does only work for English, yes. It's certainly something once we solve meetings in English, it is certainly one of the big next steps we want to do is expanding it to other languages.
So I imagine that the program sometimes makes mistakes, and I was wondering how does the data, data for mistakes get fed back into the system?
So we certainly have a set of quality control in place that review the discrepancy, or like if we get complaints, we can go back and look at the different data set, or to try to play back on exactly what happened, and then from that kind of adjust the training, or actually sometimes have to build new features to make sure that we actually capture some of those use cases.
But does that get fed back into the database somehow?
Yes. So the fix will get stored, so that since it's machine learning, once you fix the underlying data, when we train the model next, in a way, it trains on the mistakes.
Thank you so much for the talk. I wonder, can your machine talk to a real person? I mean, if someone else is not using x.ai, how can you talk to a real person? So
yeah, just to be clear, we only need, again, the experience is exactly like if you have an assistant, right? So if I have an assistant, you don't have one, you would talk to my assistant, which in this case would be x.ai. So that's my long answer saying that no, you don't need both parties to have x.ai for this to work. You have a natural language conversation with the assistant or with the AI.
How accurate is x.ai right now? And also, I mean, what if you're talking to someone who is really higher up in the company and someone who doesn't want to talk to a computer, but a real person?
Yeah, I think that's fair. So first of all, in terms of accuracy, that's something that we're working toward, and making sure that have that super high accuracy that we talked about. And so it very much depends on the case. In certain cases, we are extremely good, getting close to 100% on accuracy, and some we're still working on. Very much depends on what case it is and how complex things are. In terms of the etiquette of scheduling meetings, so part of it is the training on, would you have problem, sending, a very high up person emails, right? Or, I mean, you won't, right? Because you're used to using that as a technology that's how you communicate. So I think the personal assistant type used to carry weight in terms of I'm important now, I have a personal assistant, but now this is a piece of software. It is a productivity tool that you're using that does make life a little bit easier for both the higher up and you as well. So I mean, partially it's up to you as well. If there's I can definitely see some might be put off by the idea of that I'm talking to an assistant, but that's part of your own judgment as well.
Thanks.
What are the cases where you have close to 100% accuracy, just out of curiosity? Can you share
that? So for example, that we being able to, if we have proposed a time to you and say hey, can you meet next Tuesday at 2 p.m. and you say next Tuesday at 2 p.m. works, or just 2 p.m. works, that is very close to 100%. Yeah. Go ahead.
Can you give us a bit more details about your evaluation metrics?
Evaluation metrics.
Yeah, besides just accuracy, do you take any other factors into account when deciding if a strategy is good or bad?
I mean, accuracy is the main metrics that we drive off of, because partially we, again, have the luxuries of not real time, so that so things like turnaround time becomes a little bit less important to us, which allow us to apply more complex algorithms. But besides that, it's about getting it right. So not really. Besides accuracy, that's really the main thing. Yeah. There's a bunch back there.
Besides setting up meetings, personal assistant or assistant to a professional will probably help them in other tasks as well. Some papers or some decisions that they want to delegate. So can you sort of expand on other tasks that this could graduate to?
Sure. One of the easiest ways to just look down the job description of what a personal assistant does, and then you just go down the bullets. But to be frank, also it's just yeah, coffee. But actually more like for coffee is more on. We already get those requests right now. So you schedule a coffee chat with for me. Can you just recommend which coffee shop I go to? Or if you're booking a dinner for me already, you're scheduling a dinner for me, can you actually pick the restaurant too? So that type of very, very natural way to how do we extend the service that actually add value to our customer. That, again, our goal is to take away all these mundane, boring tasks out of your life and kind of give you back time, right? So whatever that falls into those areas is something that we're interested in. Back there? Oh.
Small follow-up.
Yeah.
Meeting part was more procedural, but you're saying now use case will become more machine learning heavy, more sort of help me tasks that depending on recommendation.
Yeah, I mean, again, it depends. Picking the right tool for the task, right? I would argue that meeting scheduling is not that procedural. I think there's a lot of random edge cases, rescheduling. Someone want to, all of a sudden today they don't want to be face-to-face anymore. They want to talk on the phone instead because they couldn't make it to the meeting, and so on and so forth. But with that said, yeah, I think it's very much depending on, it is different techniques. If we're recommending a coffee shop, yeah, we'll build a recommendation algorithm to do that. Oh.
So I have a question here. So it's about the user of this the software or this personal assistant. Do you define the user of this software as the executive of the company, or do you define the user to be also the personal assistant, the human assistant of that executive? So the point is, it could be a productivity tool for one assistant to manage the meetings or other stuff for multiple people, so that there might be a kind of a interface for him or her, a human, to just get a visibility about the schedule of different person and how it looks like, and so then he or she could just better manage everything. Just wondering if you have that thought as well.
Yeah, I mean, I think that's a decent extension. Certainly not our current focus. I mean, after all, being startup is all about focus. We want to do one thing really, really well. But yeah, with that, certainly, I mean, there is, just in a scale perspective, right, there are less assistants out there who we can help than people who need meetings scheduled. But it's a fair product extension. Go ahead.
So in your problem case, how big of an issue is context, and what's your approach to context?
So context is, it's a huge problem for I think all NLP type application. I think we are solving it in a what we think better way. Partially is the limiting of context, right? Like, we are not trying to build a all-knowing, all-seeing AI that does everything for you and tell jokes and give you the weather and everything else. We do meetings, and so when you look at the meeting scope, it is a lot more limited, which enable us to kind of do things that we just talked about in terms of like having higher accuracy and understanding the edge cases and be able to respond to you intelligently. I think that a lot of those things play against each other. So yes, it's a challenge, and I think we're addressing it.
So you are saying that Next.u could be extended to other languages, but do you think that the way data is stored currently, is it specific to English, and if you extend it to other languages, the way data is stored may change? And if so, then like, do you take any steps while designing your system to take this into consideration?
So I think it's less about the data storage itself, but more about the features that we pick. I think we do leverage English language specific features to make prediction much better, right? So for other languages, we have to leverage other features and other ways of how you're speaking or you're writing, or the style that you write in those languages. So yes, so in a way, we don't have to take that into account per se today, because we have to pretty much retrain the model on whatever new language that we have to tackle.
Thanks. Thank you. If you were to make technology choices at this point, knowing what you know, would you change anything?
I can switch out your phone.
Would I change anything? Not really. I think I'm pretty happy with a lot of the choices that we made. I mean, don't get me wrong. We had our struggle too. It's not like it's just like everything just smooth sailing. But I think fundamentally, I think we did pick a lot of the right tools that for the stage that we are in. I would say that maybe we thought about scaling almost a little bit too early. I'll give you actually another example. I think we put a load balancer in front of one of our web servers in the like day 2 of the company, and then it wasn't working because the load balancer is like, I don't see any traffic, so that's somehow not passing through any of the data. So we actually had to remove the load balancer. So again, from us, like coming from like a big data perspective, sometimes like skew how we think about what is important now versus like what is required for scaling. So maybe less about technology choices, but more about how we approach it in the beginning.
Thank you.
Yeah.
Can you give other examples? Sorry, I'm jumping in. I have a right in the meetup organizer. Can you give other examples of the technical choices that you would have done differently, like the ones that you already gave, like the top 3? Because that's the very interesting part as to what you did differently in order, like what would you have stripped off from the MVP and how you would handle the data architecture if you knew what you know right now.
So again, like back to the scaling piece, we decided we want to write, in the beginning, we want to write everything into S3 as a sort of tertiary backup. But we end up looking back at it, is that we never end up using it. Because between the master-slave database that we have and the backup service that we actually have really good sort of data disaster recovery for the stage that we're in. So we actually end up just stopping that process of writing all the data to S3 because we end up never looking into it. So that's another piece that I didn't need. And certainly spent time building it. And I was trying to find, so because we have both Scala and Node or JavaScript in the system, I think we would spend a little bit more time in figuring out how we would kind of let the two languages work together better in a way, since in terms of like how we access the database, how do we think about schemas and stuff like that.
Should we make it last one?
Yeah, hi. I understand the difference between languages, but Wouldn't it be easier just to simply translate a new language to English and then use existing model than creating a whole new model for a new language?
So I think it's not a horrible start, but I think if you start to look into languages, and especially for what we're trying to build, right? We're trying to build anything that we're going to build is with high accuracy, and losing, at least right now, translation is still not awesome, even though if you go stay at the art anywhere you do translation for. So introducing that amount of noise into what we're trying to build, I think is a significant challenge to build a good product, or for product we want to build.
Isn't it like the level of language you use quite basic? I mean, simple, basic interaction. And it's not going to be a complex language where you're going to use a lot of phrases and etc. So you can make proper translation.
It's a easier problem, but I wouldn't think it's that trivial. But for things, it's not just the language, right? It's also how you use them. Like for example, in email, people, it's not they're writing proper grammar. Like people use email like their chat rooms, but sometimes they write proper grammar. So how do you know? But even those, they almost look like different languages. Just the way you misspell things, because that's how you text, and now you're writing an email like this text. So that's type of usage. I think it's also quite different in other languages as well. Other languages take other shortcuts, as an example. So maybe you're right, and if that's the case, amazing for us. I'm super happy. Our data scientists can do something else, but I am less optimistic than that. It's fine. Love to talk.
Can you talk about the output from the NLE system for each email and how it feeds into subsequent emails? Like if someone emails me and says like, let's meet at the coffee shop near your office, like maybe that would inform, and then you have to like refine and say, do you mean like Cafe Grumpy or Starbucks? And then like, are you storing that each time, or are you reprocessing all the text?
We are storing the incremental entities, but to your point of like being able to understand what is required to schedule a meeting, like is it okay to say let's meet at Union Square, or is it okay to meet at a specific address, or do we have to be on the 9th floor, 7th floor? So I think some of those are product choices that we end up making on like what is good enough in resolving. Like for example, for time. Is it okay to say just 2 p.m. or do you have to be like 2 p.m. and what minutes and what seconds? And of course we won't. Right? To the hours where we resolve to. If you give minutes, we'll take the minutes, but we don't need the minutes, right, for example. So I think those are more product choices on how do we actually do that. On the exactly how we do that, that's a much longer talk.
As a company that is building your entire product around data science and artificial intelligence, how do you weigh kind of different groups of people, maybe not weigh, but like how do you scale? Like what's the size of your data science team as compared to your data engineering team, as compared to your DevOps team, as compared to your product management team, and like how do they all work together? Okay,
so I give you some ratios, which I think is fun. So I think your typical engineering team or technology team in startups and in other companies, you have a 7-to-1 ratio. Right? About 7 engineers to 1 data scientist. Our ratio is about 1-to-1. I think that's one very different structure than other teams. For us, 2/3 of the teams are in technology. So they're either data science. So actually, if you do the math, 1/3 of them data science, 1/3 of them engineers. Right now, we don't have a dedicated infrastructure engineer. We are actually hiring for one. Would love if any of you are interested or know somebody who would be interested in working on AI. But currently, our backend engineers also, some of them double as sort of a DevOps person or infrastructure person, which again, bringing back to some of the technology choices, enable us to do that because we don't Like, for example, like, we love Cassandra, but like, I think it takes a 2-person team to manage the Cassandra cluster, which I don't have.
Thanks.
Thank you.